Hi everyone. This video is all about how to figure out what to use for the best predicted value in the homework. So your homework problems are going to look pretty similar to this, which is what is the best predicted value for x equals 5 given y equals 9x plus 12, r equals 0.342, n is equal to 10, and y bar equals 34. Assume a significance level of alpha is equal to 0.05. So remember, in this section, we're focused on what linear regression is and how it can help us predict data. So we're going to use the line of best fit because it does a good job of predicting where the data will fall whenever we can. This question is asking us to figure out whether or not the line of best fit that we found using any kind of technology. There's another video on how to use Excel for these kind of problems. But essentially, should we use the line of best fit or not? And what our decision maker is the value of r. So if the r value is strong enough, is close enough to 1 or -1 to say that the data matches the line of best fit well, then we're going to use the line of best fit. If it doesn't, then we don't have a way of predicting the value very well. So what we're going to do is just give the requester back the average of the y values. So our options are to use the line of best fit or to just give back the average. If we can use the line of best fit, it's going to do a much better job predicting the value of y, so we're going to use it. But if we can't, we're going to use the average of the y's. So let's go about how to figure out whether or not our line of best fit will work for this data. And what it's really dependent on is the value of r and the value of n. So we need to decide if r equals 0.342 is significant enough to support linear correlation. If it is, the best predicted value is, again, do that. If it is, the best predicted value is y equals 9 times 5 plus 12, and that's because we're using our line of best fit and our value for x. We're just plugging x into the equation. So it's 9 times 5, x is equal to 5, plus 12, which is 45, plus 12, which is just 57. So if the correlation coefficient isn't strong enough, then we're just going to use our best predicted value or our best guess as y equals 35 or y bar equals 35, so the average of the y's. Okay, so to test this, we use the R table. This is linked inside the slides, but this is probably also enough to get most of your homework done because we don't usually go past into very large values of n in the homework. So the two pieces of information we need to be able to use this table are the value for alpha. If we go back up to the problem, it told us to assume that alpha is 0.05. Okay, and then the number of pieces of data, and as we already said, that is n equals 10. So I go to n equals 10, and alpha equals 0.05 at the top and gather the value for essentially the cutoff of whether or not r is strong enough. It's 0.632. So if the value of r, the absolute value, is larger than 0.632, the data supports linear correlation. So our value of r is 0.342, which is much less than 0.632. So our best predicted value is just y equals 34. Our value of r is too small, too close to 0, to be able to support linear regression. So rather than using the line of best fit, we're just going to get back the value of y equals 34 because this has shown that the line of best fit isn't actually working well for our data. So I hope that helps with these kinds of homework problems. Okay, and if you have any questions, let me know in either the discussion boards or email me or the Ask the Professor board. See you soon.